Okay. Next, we have the Archimedes Principle or concept of buoyancy. A body submerged in a fluid is subjected by an unbalanced force called a buoyant force, equal to the weight of the displaced fluid. So this is the concept of buoyancy class or the Archimedes Principle. It is gonna we have buoyant force. It is an upward force which is equal to the specific weight of the fluid times volume of the fluid displaced or volume of the fluid submerged. Vd again is volume of the object submerged or the volume of the fluid displaced. Okay, we have this one. And then we have two cases for Archimedes principle. First is in the case of floating objects or partially submerged object. So for partially submerged object, I have this one. So you have the weight, downward force, so you have the upward force of the buoyant force. So if we sum up forces vertically is equal to 0, considering upward forces as positive, you have upward buoyant force minus the weight of the object is equal to 0. So therefore your buoyant force just equals to the weight. So that is why objects tend to float, because the buoyant force just equals the weight of the object. And then for fully submerged object, this is case 2. Case 1. You have the weight, and then you have the upward force of the buoyant force. And then another one is the R. So that sum up forces vertical is equal to 0. Considering upward forces as positive, we have FB plus R minus the weight is equal to 0. Or FB now is equal to the weight minus R. Weight is the original weight of the object. R is the R or the weight now of the object when it is fully submerged. No? In Thai water, that is the weight of the object in water. W is the weight of the object in air. And then take note that it is still applicable. FB is gamma of the fluid V. In this case, your VD is equal to VO. So this is now VO, since it is fully submerged. Okay, let us answer problem number 1. A block of wood that weighs 71.2 newtons and specific gravity 0.72 is tied by a string to the bottom of the tank of water in order to have the block completely immersed. Determine the tension in the string. So this is our string. Naghikot sa ato ang block of wood to the bottom of the tank. So we have forces, weight, upward force of the buoyant force. So another force is, since we have a string, so naatay tension. Now the tension direction, asa man ang direction sa tension ani class. So kung wala pa ni siya gihikot, di ba, ang object mo pa saka. Mo saka unta ni siya mo float, but since gihikot man, mo na nga ning fully submerged siya. So therefore ang tension is opposite the direction of sa ato ang kani object. So tension is beta. That is, this is our tension. So that if we sum up forces, so ang gipangita day ani is the tension T. Summation of forces vertical is equal to 0, considering upward forces as positive. you have the buoyant force minus the tension minus the weight is equal to 0. This is the weight of the wood, no? Weight of the wood. So, ang tension may gipangita, tension therefore is equal to the buoyant weight of the wood minus the buoyant force minus the weight of the wood, from which our formula for buoyant force is gamma of the fluid. So in this case, gamma of water times the volume Vd, since it is fully submerged, so V of the wood minus the weight of the wood. By the way, ang weight sa wood is 71.2. So, kay baw na ta. How about gamma of water? Gamma of water kay baw man ta no? 9810 Newton per cubic meter. So, what about gamma of the volume of the wood? So, wala ta kay baw sa volume of the wood. Now, from the formula, gamma of the wood is weight of the wood over volume of the wood. Therefore, weight of the wood is gamma of the wood volume of the wood. Since wala tay gamma of wood, so we will use SG sa wood. So, SG sa wood, gamma of water, volume of the wood. So, this one, ang gipangita nato is kani, volume of the wood, therefore, is weight of the wood over, transpose ni, SG sa wood, gamma of water. Okay, so we will we will substitute this value. Tension, gamma of water times weight of the wood over SG of the wood, gamma of water minus weight of the wood. Cancel out gamma of water. So weight of the wood, which is 71.2 newtons over SG sa wood, 0.72 minus 71.2. So you get now the tension in newtons. 27.69. You have now your answer. Next, we have problem number 2. A block of wood floats in water with 7 inches. So this one in water, it is projecting 7 inches above the water surface. It is then placed in alcohol of specific gravity 0.82 and projected 4 inches above the surface. What is the specific gravity of the block? SG sa block of wood ni. Wood man no? Okay. Now, in water, sorry ta sa water, yung float man siya, so buoyant force is equal to the weight of the wood. No? That is because it floats. Gamma of water times Vd. This is gamma of, from the formula sa gamma of the wood is equal to weight of the wood over volume of the wood. So, gamma of weight of the wood, therefore, is gamma of the wood times volume of the wood. Now, gamma of water, volume displaced, is equal to area times this height. If this is H class, and then this is 7, therefore, kani siyang height is H minus 7. So, area times H minus 7. That is the volume kaning naa sa ubos. H minus 7. Volume of the wood. Total volume of the wood is area of the bottom and the height, which is H. Now, ato ang substitute na. Let us substitute, by the way, let us substitute the values of gamma of the wood with its specific gravity aron magawas ang atong gipangita nga sa specific gravity. Gamma of the wood is Sg of wood, gamma of water times volume of the wood, area times H. So that cancel out area. Gamma of water also is cancelled. Sg of the wood therefore is H minus 7 over H. So, ano ba tataman? Next, in alcohol, the same thing happens since still floating. Yung float yapon siya. Fb is equal to weight of the wood. Gamma of the fluid, which is water, alcohol. Vd. Gamma of wood, volume of wood. Now, for alcohol, that is, gamma of alcohol is Sg of alcohol, gamma of water. The volume displaced is area times na submerged kani. This is H minus 4. H minus 4 ang na-submerged. This is Sg sa wood gihapon, gamma of water, area times the height H. Area is cancelled. Gamma of alcohol is cancelled. So Sg of wood therefore is Sg of alcohol, H minus 4 over H. This would be our equation 2 since both equation 1 and 2 are equal to Sg of wood. So we can have equation 1 and in equation 2 equate na to sila. So H minus 7 over H is equal to Sg of alcohol, H minus 4 over H. We have now the value of H, substituting the value of Sg of alcohol, that is 0.82. You have now your H, which is 20 and 2/3 inches. So unit is in inches. And so, nanatay H, and then from equation 1, our Sg of wood now is 20 and 2/3 minus 7 over 20 and 2/3. So, ang sama ni answer ani? 0.66. 0.66. Okay. Last one. The density of the ice is 917 kilograms per cubic meter. Approximate density of seawater in which the iceberg floats is 1025 kilograms per cubic meter. What fraction of the iceberg is beneath the water surface? So since ga-float man ang iceberg. Okay. So therefore, buoyant force is equal to the weight of the ice. When you say buoyant force, that is gamma of the fluid, which is seawater, times volume nga na-submerged kani siya nga volume, Vs, volume submerged, is equal to gamma of ice, volume of ice. Now this is rho g. Gamma is rho g, right? Rho of seawater times volume submerged is equal to. How about gamma of ice? This is now density of ice, G, V of ice. Cancel out. Now, ang gipangita na to, fraction of the iceberg that is beneath the water surface. So, Vs over the total volume of the ice. Mana siya ang gipangita na to. Si Vs over V ice. So, this is actually ice over seawater. This is size 917 kilograms per cubic meter. This is 1025 kilograms per cubic meter. Cancel out. So you now get 89 then times 100%. The answer now is 89.46%. Okay.